Hey guys, so today in class we discussed this topic. You can read it right here. I hope it may not be large enough, but it says finding, evaluating, and interpreting an inverse function for a given linear relationship. So we did get the answer in class, the solution that Alex wants, but I am not confident in how I explained it conceptually, really understanding how the notation changed or why it is what it is. So I want to make sure that we cover this again. This is a different one from what we had in class. My only issue is that I think this problem is a little bit too large to fit on my screen. You see how small this is right here? So what I'm going to do is I'm going to make myself disappear, and I'm going to make this problem really large. It's going to fill up the screen here. And I would like for you to pause the video. I'm only going to do it momentarily, so you're going to have to pause the video, write the problem down, and then what I would do is try to maybe zoom in and maybe show a part of the problem so that I can see it on the screen. But that way, some of it's probably going to be cut off, but that way you will have the problem and we can work this out and all be on the same page. Okay, so fingers crossed that I can do this correctly. So here we go. All right, so let's jump back in to this. I am going to try and zoom this in if it will let me. Give me just a second. Sometimes my computer works for me. Sometimes it does not. Okay, so I think this is a little bit larger where we can see it. It says that Mary is walking. D of T is given below. And it is her distance in kilometers. Oh, it is moving for me. From Newberry Heights after T hours of walking, and it gives us D of T. So let's write this down first. So I have D of T is equal to 15.5 minus 5T. And if you don't mind, I'm going to turn these lights down because I want to make sure you can see this. And I'm not interested in you guys really seeing me so much. I want to make sure that you can see the work. So here's my D of T, and it says to complete the following. Give me just a second. So I'm trying to maneuver in the dark. So I'm going to have to zoom this back out. It says which statement best describes D inverse or the inverse of D of X, and it asked me to find. So here's the thing. Here's what I want to first find. I want us to find the inverse of D of X. All right. Now it gave me some information here. It told me, I'm going to write this over out of my way. I hope you guys can see this. I have X is equal to D of T. And then I also have that T is equal to the inverse function of X. Okay, so I see down here that it's asking me to find that inverse function. So let's first find that. If I do that, I know that this right here, that is my original function. That is my original function. That is not my inverse function. But to find my inverse, if you guys remember what we did in class is we substituted the X, and if there was a Y here, we substituted the X and the Y. Now I'm going to do this a bit differently. What I'm going to do is I'm going to take my known pieces here. I'm going to use this. I know that X is equal to D of T, so I'm going to put that X is equal to that 15.5 minus 5T. Now again, like I said in class, I usually substitute the X and the T, but I'm not going to do that here because if I do, then my notation is not as straightforward. So what I'm going to do at this point is I am going to, let's use a different color. I am going to solve for T. Okay? We're going to solve for t. So that means I'm going to subtract, I'm using a yellow and a green, and they look very much alike here. So my apologies. I'm going to subtract that 15.5, and that's going to give me x minus 15.5 is equal to negative 5t. Then I would divide both sides by negative 5, and that will leave me with t is equal to x minus 15.5 divided by negative 5. And I'm going to flip this around just because I like to have my t on this side. I have t is equal to x minus 15.5 divided by negative 5. Now, that is my inverse. But they do not want t. They ask me to find this. Okay? But what I know is that t is equal to the inverse function of d of x. So what I can do is I can replace, let's pick a color. I can replace, because of this statement here, all right, I can replace this t, because t is equal to this expression, the inverse function of d of x, I can replace t with this. So that's going to tell me that the inverse of d of x is equal to that x minus that 15.5 over negative 5. So in class I was having trouble explaining exactly how that notation ended up being what it was, and I know this looks really straightforward, but it's because I switched to my variables to begin with, and I didn't here. So I just kind of left t there. I solved for t, and I replaced t with the inverse function of d of x. Now that takes care of one part there of my problem. The other part of my problem is asking me, and let me zoom in, and you can pause the video here if you need to. So let me switch here for a second. It's asking, let's see if I can zoom this out for a minute. It's asking which statement best describes the inverse function of d of x. Okay, so let me get my mouse just right here. So let's, if you don't have this already, fine, hit pause. I'm going to erase it. But what I want to do is take all of this away. I need this down here. We will keep this. I need that answer. But we've got to talk about what that means. What does that stand for? What did I find? Okay, let's leave the original function. And I hope my board does not look too messy. I'm trying to erase it without erasing what I need. But let's talk about this. That original function, it tells me that t stands for hours. And it says d of t, Mary is walking, d of t given below is her distance. So this is my distance. So let's think about this as a mapping. So what I know is that my hours, that is my independent, P-E-N-D-E-N-T, excuse me, I'm a math teacher, I can't spell, independent variable. Whereas the d of t, that is my output, and I could have labeled this as my input, but this is my dependent variable. So if I were to write this out as a mapping, if I were to try to explain this, so over here I could say that the numbers that I'm substituting in is my t. Given my t, so let's say the number 1, there could be tons of them, a lot of them. Well, for this particular equation, I know that if I were to substitute 1 into this function, that would give me d of 1, which gives me 15.5 minus 5, which gives me 10.5. That gives me my distance, okay? My input, output, domain, range. Another way I could think of this is that function gives me, it expresses the distance as a function or using your time as a variable. Now, I found the inverse here, okay? So if I found the inverse, what happens? Your domain and your range, they switch, okay? So now, when I find my inverse, this happens. I'm going backwards. My time is now a function of my distance. Now, knowing that, let's see if I keep messing this thing up. So, if I look at A, which one of those, part A, would explain what I just said? The inverse. The reciprocal of her distance from Newberry after walking X hours. No. It says the amount of time she has walked in hours when X kilometers from New Bern Heights. I think that is my answer. That right there is my answer, because this, my distance, X, is my input, my output is my time. So you have to really draw this out, and you really have to think about it. So that's how I get, I'm going to say B as that first part of the answer. The second part here, it's asking me to find the inverse function of d of x, which I did. It's highlighted in purple right here. Can you see that? The tail end looks like it's cut off, but there's nothing missing there. So that is my inverse. The only piece that I am missing here is that it is asking me to find I need to substitute 8.5 into my inverse function. So that is literally taking 8.5 and I'm substituting that into x. So that is going to be 8.5 minus 15.5 divided by -5. And if I 8, 9, 10, 11, 12, 13, 14, 15, that gives me -7 divided by -5, which I could simplify into 7/5, which is 1 2/5, which is 1.4 miles. And I'm not sure how they wanted the answer. Let me see exactly how they want you to put the answer in, because I like to look at that. The answer that they gave, and I will show you guys here, the answer that they gave was 1.4. So you simplify, you get 1.4 miles, and that is it. So I hope that this helped a little bit. If you still have questions about what I did, about the notation, just shoot me an email, and I will be happy to address those and help you all that I can. All right? You guys have a good day.